So when I was thinking about giving this talk or what should happen, it's like, the history of Benchee. And I was like, okay, like when did it actually start? What happened? Where was I in life? Where was life in general? And so I went to Git and I took a peek. And yep, the initial skeleton of Benchee, which is just a mix new thing, was on Sunday, May 22nd, so like a little bit more, like 2016, so a little bit more than 9 years ago, actually. And about 2.5 hours later, I created what I back then called the first meaningful running version, which I agree with. It is the first meaningful running version of the library. So that was 9 years ago, and I know like when you had Björn like speaking this morning, when the time frame started, when I wasn't even born, to the time when I was a toddler, it's not as impressive 9 years ago, but for me 9 years ago was a long time ago. So this was me like not exactly 9 years ago, but this was me November of 2015, the last time I've been to the States, and I was at RubyConf in San Antonio, and like so you can see me holding a Ruby, so like I came from Ruby. I didn't come from Erlang, and that's sort of like the way I found myself in. So like, and I'm asking myself sort of like, what drove that guy to do all of this stuff? And also, by the way, as a visual comparison, now I look like this. So it doesn't work as well with the other screens. You gotta look to the main screen. I'm sorry, but that's what happened. And then, what state was the ecosystem in? And so Elixir was in version 1.2.5. That was the most recently released Elixir version. And that version deprecated dict, hashdict, set, and hash set. For all the new folks, yes, we had these weird data types back then, and we had to deal with them, and you don't have to anymore, which is great. It also introduced the with statement, which you've seen also a couple of times today, and which is largely useful. And like the changes in the language were so meaningful that actually there was a program Elixir 1.2 book that was released just for this release, because both the XRM manager, all the deprecations, and the with statement were so like such massive additions to a language that basically we required a new book. Talk about that. And then Erlang, the most recent release was 19.0 RC1. So like my Beam history only goes back to like maybe Erlang 17 or Erlang 18, something like that. And in those release notes, something that we've also heard mentioned many times today, or like a couple of times, genStatem was introduced in Erlang 19. Sort of like, and that's like a staple, everybody uses it. Gleam did not exist. So I checked this, and Wikipedia actually says, I think, like 12th or 11th of June the same year. But the first commit in the repository is like 30th of June, and I messaged Louis, like the weird British guy who invented it. I was like, Louis, what's up with that? He was like, I have no idea why they picked that date. And he contends that even that version of Gleam isn't actually even Gleam. Afterwards, you have like 2 years of silence until he really started working on Gleam in earnest. So I know everybody loves to talk about politics these days. So Barack Obama was the president in the USA at the time. Angela Merkel was the chancellor in Germany and would be for the next 5 years still. So like it seems like a long past memory. And Stranger Things hadn't even released yet. We are like in what, like, I don't know, season 4 of Stranger Things. I think most of us still believe that like Game of Thrones was a really good TV show that was like, the best of the best. Not so much anymore. And so I went and asked myself, what drove this guy? Like, why did he do this thing? How did he end up here? So this talk is called Benchee, 9 years of benchmarking on the Beam. You can call me Toby. You can find me anywhere on the internet as @Practop. And what we're going to do here is we're going to look at Benchee, what drove me, the early days, some of the discoveries made. We'll talk about some Beam performance characteristics. We'll talk about open source. And it's just a big mishmash of ideas where like tell a story and then like deep dive at some point. And it is supposed to give you hopefully some inspiration, for open source and some knowledge about performance. And hopefully we'll get more hands raised next time if anyone has used Benchee. Men nu, varje gång jag presenterar I Sverige, jag måste prata lite svenska. Det lorden jag glömde. Så jag bodde I Karlskrona och jag har studerat på Blekinge Tekniska Högskola för 8 månader I 2011 och 2012. Och så jag pratar lite svenska. Jag har ätit glass på glaciären. Jag vet vem Orup faktiskt. Jag var på en Orup-konsert I Karlskrona. Men nu, vi har mycket att prata och de andra, de förstår inte svenska så vi ska prata engelska nu. A little well-studied party trick. So, no, I can actually speak Swedish. Anyhow, so this was already a bit taken away, but like, who here knows what a benchmark is? Okay, that's most people. Who here knows Benchee or has heard of Benchee? And then, like, I mean, the other question we already had, who here used Benchee, there was like 4 or 5 people. It makes me very sad, but hopefully we can increase that. So, also true story. So, what's a benchmark? And I've given many talks about benchmarks at like multiple conferences, many Erlang-related conferences. But actually, in 2017, at I think the last Erlang user conference, I was here and I was giving a talk about benchmarking. It was the last time I was in Stockholm, and I woke up. Well, I couldn't fall asleep because I always want to make my presentation better, and got this. And then I thought about a new way to explain what a benchmark is. It was 2 a.m. in the morning. I was like, do I get up now and adjust my slides at 2 a.m. in the morning to use that explanation instead of what I have for the talk that I'll give tomorrow? And I did. And obviously, what other choice did I have? Sleep is for the weak. And you will see that explanation now, and I hope it is worth it. So, what is a benchmark? A benchmark is basically like these little bunnies. You try to feed the benchmark some input, and then you see how fast does the bunny process the input. Sometimes the input is mishandled, and then the benchmark misbehaves. So you got to watch out for that. You got to have good tests. But basically, you try to time them how fast they are. But you also got to be, very, very of resource contention, because if you run too many benchmarks at the same time, then not everybody gets to the input, and the functions can produce the input as fast as they can. So basically, benchmarking equals put food into bunnies and see how fast they process the food. That is the essence of benchmarking. So we want to measure a time usually when we talk about benchmarking, but there's many more modes. And so a very valid question is like, hey, why don't I just use the time utility on my computer and do like time, execute my script, and see how fast it's going? And the question here is like, what do you want to benchmark? If you do it like this, you time the entire executable essentially. You measure the startup time because the beam needs to start up, or the JVM or whatever, it needs to start up to actually be responsive. Then there's a time which we call warm-up time, which is the first time things are executed. You maybe got to establish database connections, you got to build up a cache, something. So your system isn't at full performance yet. This is way more important with like a conventional JIT that like looks which code paths are used a lot, and then only JIT compiles those paths, which, as we learned today, the beam doesn't do that. The beam just JIT compiles every module on load, basically. But especially there, this is very important so that you get like the hot performance, as we call it. And then we have what we usually call the runtime. So like your system's warm, your system's booted, and then you care about how long does it take for functions to execute then. And usually in like web development or also embedded development, that's what we care about, because like a system usually runs for hours or days or something. So like the runtime performance by far outweighs the others in its importance. But for instance, if you write like a CLI interface, like just a little CLI executable, then you care about the whole thing with startup and warm-up, because people just invoked one. So like the lesson here is always measure what you actually care about. And as a small example, sorry, this is not Erlang, this is Ruby, but it's one of my favorite benchmarks, so I have to show it to you. On the x-axis, you have the number of iterations that like a particular code was executed. You can see here that on the first iteration, Truffle Ruby, which is like a super advanced JIT compiler, it takes by far longer. So if you measure that one iteration, you can say it's like, I think, 3.5 times slower than the actual mainline Ruby implementation. But if you walk along, you see that towards the end, iteration 12, 13, and 14, it is actually by far faster. Then it's like 3 times as fast as the normal Ruby implementation. And so again, it depends on what you measure. So like in the main Ruby repository, they measured this one, obviously, and it was like, oh, we're so much faster than all the other Ruby implementations. But like if you actually care about the hot performance, then I think this is the much more reasonable benchmarking number. And so you get a difference from 3.5 times slower to 3.5 times faster, just by the way that you measure things. So Benchee. This is basically what Benchee looks like. So you handed a map from like a name of the benchmark to a function that's basically the function that you want to benchmark. You have a configuration that you pass in the end where you say like, okay, I want to run this for 10 seconds and I also want to measure memory for 2 seconds, and then you run it. Just usually, you just have a script and you just say mix run that script. And this is the output of Benchee. And we will go into some parts of this, but the main point for me here is that like everything here has a purpose. Everything here popped up because I or somebody else had some kind of pain. So first of all, it shows you some system information about like where is this benchmark being run on. Then it shows you the configuration, sort of like what are the parameters that I configured this with, like how long does it run and everything. Then it also shows you some progress on like what's happening right now, because sometimes things hang, you want to know when or why does it hang. And then it shows you results, which we'll zoom into really quickly. This is just a console formatter, but it has this thing called IPS, which is iterations per second. Why do we have this? It's much nicer to graph than time, because for iterations per second, higher is actually better. And like it's nice when you look at the graph, and the big graph is actually the good one that you want to have, and not like the low one if you just measured time. And then it shows you average, deviation, median, 99%, and there's many more statistics you can configure to print out even more. And then it shows how much slower is it, and that stuff. And so we learn that flat map is much faster than map.flatten, which we'll also get to in a second. Benchee has multiple formatters with which you can produce many things. And so there's an HTML formatter, which you can then also get these wonderful graphs out of, which is something that I really like, because then I just have these graphs, and I can just copy them into my presentation, but work is done. So I love that. My own personal description for another talk of all my open source journey of how I, in all my artistic talent that you can see, describe Benchee is just I wanted to make benchmarking happen, put a little bit of Elixir and Erlang on it, and then just put a lot of love in it and generate a lot of reports. And I think, looking at this room, probably I haven't quite made it, so there's still a lot more work to do. But there's many moments for me before I had the feeling that yes, we made it with Benchee. So there was a book release called Adopting Elixir many years back, and there's a one-page section about benchmarking, and it uses Benchee, and that's the first time that any library I had ever mainly offered appeared in a book, to the best of my knowledge, and that made me very happy. But also I know that Benchee is used to improve the performance in Elixir itself, and I also know that my friend Miha Muscala, who works at WhatsApp, who does all these amazing stuff like the old JSON library and the new JSON library that is now inside of OTP, he uses Benchee extensively to benchmark these and make them as fast as they possibly can be. So that's where I think we've made it. Anyhow, so back to that fucking guy, right? So what was I doing back in 2016? These are some other photos I found in my photos folder, which is I was working at a company called Leafree, which did same-day delivery, which is a complex business model in my beautiful handwriting for that. And we wanted to do this something. We wanted to implement courier tracking. This was even, a little bit before in November of 2015, which is we want to have live locations for where our couriers are. And as I said before, I came from Ruby. And Ruby isn't really a great fit for having a WebSocket open and, the concurrency and all of that. So we were looking for other solutions. And so we ended up looking at Elixir, and we were okay, let's try it. Let's build a separate service for this with Elixir. And just on the side, one of the major reasons why I also really wanted to go into Elixir, or trusted Elixir, is because José Valim, many may not know this, but he was a Rails core team member before that. He also wrote books about Ruby, and one of that was crafting Rails applications, where he goes into extending Rails and making it better. So I trusted his vision for the programming language because he knew what it's like to build web applications. And so I knew that, I felt that I could trust him to make good choices in language design, library design, and whatever, so that we can have a good and thriving ecosystem. Anyhow, this is sort of the architecture we came up with. It's not super important, but we had another Phoenix app, and we had JWTs for authentication, and then the Android Courier app talked to that, and that all worked, and that was a really great result. So that's how I got into Elixir back in 2015. But how did I get into benchmarks? And one of the major reasons, there's two, was this talk, 2014 at Baruco in Barcelona, by Eric Michaels Ober, which was called Writing Fast Ruby. And in that, Eric makes the argument that there's not always a trade-off between writing fast code and writing idiomatic code. In many languages, or in an optimal case, the fast code is the idiomatic code because the language is designed in a way that sort of it encourages you to write idiomatic code, which will then also be fast. And he showed a bunch of benchmarks of really common Ruby code that there was a much faster version that looked much better. And I loved that idea. And later on, I was working on a Ruby open source library called Shoes, which, does anybody here know Shoes from the Ruby? Wow, 2 people, so that is amazing, as opposed to Benchee, that is amazing. Which it was a toolkit to write UI or GUI applications in Ruby. And we had actual performance problems in there, which you could see because we were writing a game in it, and the FPS would be very low. And so we tried to fix them. And my co-maintainer Jason taught me how to write benchmarks for that. And so I wrote this blog post about meta-programming performance in Ruby and what you need to do better to have it faster. And so I liked that, and I really got quite a good liking for benchmarking from those. And then I wrote another blog post, which was also still in 2015, where I just took all the Ruby implementations that existed at the time and benchmarked them against each other on a Go engine, which uses Monte Carlo tree search that I wrote myself, so an AI that plays the game of Go with you. And that was super fun, and I just did all of that for fun. And here are some of the benchmarks from that, where you can see that basically 1.9 and 2.2 is the major Ruby implementations, but you can see that JRuby, which is a Java-based implementation, is much faster, and then the truffle Ruby that we saw before is even faster than that. And even more stuff. So this is about let's say accessing structs. Basically, there's a very anti-pattern way in which you can define the struct and use it in the same place. That was super slow. And I wrote another benchmark for that. And now you might be, okay, I became a bit of a benchmarking nerd. And the question is why? And as much as I love feature development and shipping value to users, it's you never know if the feature is actually going to help users, right? It depends on them. You don't ever know if you get it right until you ship it. With benchmarking, I can take a piece of code, and I can just tell you, I just made this piece of code 5 times faster. I know I made it better, basically. And that is something that I personally deeply enjoy about benchmarking. And yeah, this is that benchmark. So back to learning Elixir. So this was new for me. It was okay, I wasn't that used to functional programming. We have this weird data type called linked lists, and I don't have random access to my array anymore. What's up with that? How do I write code in that? And so I begin asking myself what's fast and what's idiomatic here? And that is for me, I don't know if anybody knows the thing of Kent Beck always writing an XUnit framework to learn a programming language. To me, I feel I write benchmarking libraries when I learn new languages because I want to exactly explore that, sort of what's fast, what is a good thing to do here, what is idiomatic. And essentially, I was also asking myself, what's my benchmark IPS? Benchmark IPS was the library that I mostly used in Ruby, but fun fact, I also already wrote my own library in Ruby because benchmark IPS does something wrong, basically. Benchmark IPS first runs all the warm-up for all the functions, and then it runs all the functions and measures them. But the problem is if you have a highly jittered runtime that really looks like code paths, running the different warm-ups can interfere with each other and make code actually slower again. So you need to run first the warm-up, then the code of the function, then next warm-up, and then the function. And because that really tainted the results, I had to write my own benchmarking library in Ruby already. But one thing that always really, let's say, bothered me about benchmark IPS was it wasn't really extensible. I ran it and I had the stuff, cool. But as I said, I love that I can generate graphs with Benchee, but there was no extension point in benchmark IPS where I could create graphs from it. And so what I did is I took the output and I copy and pasted all the numbers into a spreadsheet, and then in the spreadsheet I made the graphs, and it always seemed like a big waste of my time, and so I wanted to do it better. And that is, one of the best reasons to get into open source is this sort of scratch your own itch kind of thing. You have a problem, you want to solve it. And so first, really back in the day, there was another benchmarking library in Elixir called Benchfeller. So first, I tried to contribute to it. However, I found that it used the DSL, so it used macros and metaprogramming. And I am of the opinion that macros and metaprogramming should only ever be used if it's really, really necessary. If there's no other way to do this, because I can always take functions and put a DSL on top of macros, but it's very hard to have macros on top and then wrap them in functions. And I didn't think that actually that macros or metaprogramming would be needed for a benchmarking library. Also, the code wasn't really well tested. There was lots of out-commented code for memory measurement and stuff like that I didn't quite like. And it also didn't support any warm-up. And I didn't take this decision lightly. And actually, in my mind, I opened this pull request and waited for 2 weeks before I started working on Benchee. But if you check the date, it's the same day that I started working on Benchee. So my memory clearly betrayed me there. I think I waited 2 weeks until I actually released the first version of Benchee there. But so I decided to create my own thing. But I want to highlight that is a very important decision to extend versus create, because let's face it, we're sadly a relatively small community, which has benefits and which has also drawbacks. But especially in such a small community, I think you should first look, can I help somebody else with the project that does the same thing or a similar thing than my project before I create my own, because we don't want to have so much fragmentation in the ecosystem. So back to the first commit. So by the way, I realized when I looked at my calendar, Sunday, May 22nd, the day before was the birthday party of my partner, and I think we partied pretty long. So I don't know how I got up at 16 o'clock and wrote some Elixir code, but I did. So let's have a look at the first meaningful running version of Benchee. And those are the functions that it has. So basically, it has an initialization function for the config, it has a function that does the benchmark, and then it reports on it. So this is really the first commit with 60 lines. I cut some stuff out, but I thought it was kind of interesting to see what was already there. So the first one just really takes the time that was in the configuration, converts the seconds to microseconds, gives back some structure, goes on. The benchmark function you would think is the more interesting one, but the actual interesting stuff happens in do benchmark, where it actually does the benchmark, and all the rest of that function is just create some data structures, add them back into the suite, and return the suite, which is the big data structure that held everything. And so do benchmark, and this is still at heart how Benchee works today, is when we've taken more time than the time we configured, then we just return the results. Otherwise, we measure the call, take the runtime, we add the runtime to the results, we add the total runtime to the runtime, and then that's it. And measuring, just OTP, just time ITC, beautiful functionality that most of you have probably seen. And then we run into the report, and the report just tells you, okay, there's all these things, there have been these many samples, and this is the average, and this is the average calculation. By the way, all the code I've showed so far, there's I think at least 3 subtle bugs in there. Kudos to you if you found them, but they have been fixed later. So why would we not stop here? Still want to do memory measurement, many more statistics. I don't have my CSV export or my fancy graphs yet, so that's why I kept pushing. Then I looked in the logs, okay, what kept I pushing? Okay, there's a lot of code here that I pushed on the 28th of May and the 29th of May. And so I looked again at my calendar, and turns out I was at a wedding that day. So this is the groom and the bride. You can see me over there, or you can also see me there. And I was like, what the hell, Toby? What was I doing? I was like, well, when did I program this? And then thankfully, I left a little hint for me, #working from the train. It's okay, I worked on the train to the wedding and back from the wedding. Okay, cool. So I was I couldn't possibly have done anything interesting during that time on the train. Why would I? Then I found this commit, high-level interface to quickly run benchmarks for multiple functions. And that is the run interface that Benchee still is the main interface into Benchee to this day, and it still looks very similar to what it looked like back then. It's we initialize the configuration, we run the benchmarks, then we gather some statistics about it, we format them into some output, and then we put out the output. So found it quite fascinating. So on June 5th, so about 2 weeks later, I was okay, let's release a first 0.1.0. So, okay, let's roll. I wrote a blog post about it like 2 days later where it was like, here, this is Benchee and like why I wrote Benchee and so forth. And then also, again, for me, really interesting, I had a whole section in there about designing a benchmarking library. And that design still holds true today. And so let's talk about the design of Benchee a bit. At first, this was really vexing for me. Like, I've done a lot of benchmarking, I've written benchmarking libraries, but like, how would I design a functional benchmarking library without any macros and all of that? And so one concept kept popping in my mind from what I learned was that functional programming is like a functional transformation. Like, if you make a sandwich, you don't take bread and like mutate it to add butter and cheese and ham or whatever to make a sandwich. You take the bread and then you apply a function, you return like a new sandwich, but this time it has butter on it and cheese and so on. So that's like the functional transformation, right? And I was still unclear how that would work. But then I also read the Programming Phoenix book, and it has this brilliant example where it says like, is Phoenix or is functional programming a good fit for web development? And then they go like, of course it is. We take like a connection, which is the URL that we're getting in, route it to the right endpoint, to the right router. That one goes through some pipelines. That goes to the controller. That goes to the model and to the view. And it has some side effects, right? It goes out to the database and stuff. But in the end, you return like an HTML page or JSON response. And so you turn the input of that URL and the body maybe of it, and you turn that into HTML or JSON. So it's not purely function, but it is a functional transformation. I was like, that's kind of cool. And so this is the run function in Benchee as it looks today. We have a couple of more steps than we had back then in the day. But we still start with, we get a configuration, we initialize it, which means like we take a bunch of, we transform the configuration a bit, we take a lot of, we apply a lot of defaults and so on. Then Benchee system gathers the system information that you saw. Then we add the benchmarking jobs. Collect is the one that actually does all the measurements. Then we calculate the statistics. Benchee load is the one like you can basically save a Benchee benchmarking result and load it back in to have a comparison like between like main and the branch or something that you're running. Then you can run multiple formatters, you output them, and then in the end you can also run one of the built-in profilers in the end, which was a feature idea by Jose actually. And so that's what Benchee is, just a function transformation. I get a config in, I produce an output for you, and all of these steps are there. So that's sort of like a pipe architecture. But like the question is like, why is that useful? And it is useful because I can also take each of these steps and basically replace it with another step that adheres to the same interface, essentially. So Benchee doesn't only measure time. Benchee can also do memory measurement, which was really tough to get right, actually. And Benchee can also measure reductions, which reductions are like a unit of work on the beam, let's say, on the high level. And also, like on the output, we can have many different ways in which we do our output, like not just the console, but CSV, HTML, Markdown, whatever you name it. And that's sort of like the extensibility that I was talking about that was missing with Benchmark IPS and how I brought it into Benchee. And I've also been dogfooding this since 0.1.0 because that already released along with Benchee CSV so that I can have my graphs and not have to type it myself into the spreadsheet. And that was a separate repository straight from the first version. So is Benchee HTML and Benchee JSON, so that I feel the actual pain that actual plugin authors would also have. And also, the run interface is just for a nice working version. All of these functions here are public. So you can use all of them, and you can exchange a layer. So like you can change how Benchee works if you really want to at any point in that. And I think that's also really beautiful. So for instance, I've often thought about, maybe I could write like a load testing library based on Benchee by just replacing the collect step, for instance. And so was that all a success? If you search HexPM for Benchee, you find these packages that are not Benchee itself. And these bottom ones, I didn't write. Like somebody else wrote them. And that is enough for me that I would say that is a success. So for instance, Benchee Markdown, I love that. Like I never had the idea to like have a format that puts out valid Markdown, but like somebody else did, and they wrote it, and that's really great. And then for instance, for Gleam compatibility, there's Glitchy. So I love that as well. I mean, it was sad because I wanted to write that in Gleam. That should have been my introduction to Gleam, but now it wasn't. But like somebody else did, and so I'm really happy about that. And even way down there, somebody wrote Benchee DSL, which is basically macros and like a DSL on top of the function. So if you want to have that macro X unit type of like layout. And again, that goes exactly with what I wanted to achieve. Like, yes, you can build all those macros on top of Benchee if you want to, but I don't want to maintain it. And also design-wise, there's a lot of stuff in Benchee where I say, like, I would love to have it in sub-libraries. So for instance, the statistics module already has a sub-library called statistics, because in part also so it's reusable, but also because it runs property-based tests, which are great, but take up like quite some time. And so that is separate. I would love to have a separate library for the system stuff, for the system information gathering, because that gets quite gnarly if you want to support Windows, Mac, and Linux, and Solaris, and whatever else. So on we go. One of my favorite things was then, I was new to functional programming and like the beam and everything, and everybody was talking about tail call optimization, and like tail call optimization, you need to have tail recursive functions, and I was like, oh wow. I wanted to learn, okay, so how bad is it if my function isn't tail recursive? So I wrote a couple of map implementations. So this is the body recursive map function, which is quite easy to write, but it's not tail recursive because the last operation here is actually sort of like the list prepend. So that's why it's not tail recursive, because map body isn't actually the last call. And here's the tail recursive implementation, which it is tail recursive because there actually the call to the function itself is the last call, but because that messes up the order, you need to reverse it in the end. So I benchmarked that. And those are the results. It's maybe hard to see, but actually the body recursive function was the fastest. Like actually, so the tail recursive functions were slower. Even if I took away the reverse, they were still slower. And so that was really surprising for me to see, and that's also why I wrote a blog post about it. And then there also what I found out during that thing, because like you get all of these interactions then, which are great, is that the argument order on the beam actually matters. So pattern matching on the first argument is much faster, or like reasonably faster, measurably faster than pattern matching on the second or third argument. And if you remember my implementation, I pattern matched on the second argument. And so pattern matching on the first argument is actually much faster. And so here's a couple of edits that I made there where you can see that those also directly went into Benchee features. So I was like, oh, and added to the blog post, I added CPU and US information. So now Benchee gathers those for me. And was like, hey, it was pointed out that, you know, performance characteristics are different with differently sized lists. I think I benchmarked it with a list of, I think, 10,000 elements or maybe 100,000. And so with bigger inputs, that changes, and then the tail recursive functions are actually faster. And also, by the way, I love that in our community, right? I posted it on Elixir forum, and I'm not sure if Robert is here. Robert probably doesn't remember, but like Robert also in that discussion pointed out that, hey, the main point of tail recursive is also that, you know, if you have something like a gen server, which is implemented as a tail recursive function, it never blows up the stack because it just keeps running the tail recursive function endlessly. And so like I updated the blog post, I learned something. And so that was really, really great. And like, I still love that benchmark of like the tail recursive versus body recursive. I love it so much that I did it again last year. And I thought it was the first time I redid it, but I realized I already redid it 5 years ago. But I redid it, and one of the really cool things that I noticed is, so this time I benchmarked it over Elixir and Erlang versions. And the cool thing was that at that time with an input of like 100,000, for instance, the Elixir 116 and OTP 26 was faster than everything else. So even the body recursive function was faster than all the other tail and body recursive functions, and like the tail function with the adjusted argument order was the fastest by far. But like whatever you did on OTP 26, it was faster than 24, which 24 was the one that introduced the JIT, so actually expected a speed increase there, but it came with 26 for that particular benchmark, and all the others. So like we had really massive speed gains thanks to the Beam team, which was really awesome. Benchee can also generate these kinds of graphs, which are box plots. I don't have the time to explain them to you, but like they're really cool graphs when you do this kind of work. And the other thing, again, is that inputs matter, and quite bigly. So here I did the same benchmark, but with an input list of 10 million, and now you can see that all the tail recursive functions over all the different Beam versions and Elixir versions are much faster than the body recursive functions. So that was cool. And then, sort of like in August 2nd, so this was like, I think about 2 months after the Benchee release, I opened an issue at Elixir where I was like, hey, like somehow using flat map is slower than map and then flatten. And like I'm used to this being faster, and I didn't understand why. So this was also always the first benchmark that I did with Elixir, with Benchee. So it was always my example, was always like, this is weird, flat map should be faster. And like over those 2 months, like I checked my implementation was right, and I couldn't understand why it would be wrong. And so I posted it with this benchmark where you can see that sort of like lists flat map, so the Erlang version, that one is by far the fastest. Map and then flatten is fast, but then flat map is much slower than map and then flatten. It's like, that shouldn't be possible. So I was like, hey, what's up with that? And I swear, 17 minutes later, Jose William responds like, yeah, that's weird. Here's 2 different implementations. Could you please benchmark those? And I benchmarked them both, and they were both faster than the initial one. And like that was for me the point where I realized I may be a very good programmer, but I don't think I'll ever be like Jose William good. And that's fine. I need to live with that. I think most of us need to live with that. But that was like a really cool point where through that, then he had an implementation that was as fast as the Erlang one, essentially. And so I helped in a little way, to improve the performance of FlatMap in Elixir for all of us. So this is like a little bit of a story time. This was a story about like how it helped the ecosystem. Here's another story of like how it helped me at work, which again, we had this live career tracking and like we deployed it. It was fine. And then I look at the error tracking and suddenly it goes boom. I was like, what is happening? And I get my Elixir DB connection. And I was like, what's happening? And then it goes like, that's basically when you get a timeout. Something took too long. And I was like, OK, let's write a benchmark for this. So the particular error was in like fetching the latest courier location for a given courier. And then I was like, OK, we have a database view here that handles this, which is, I think, what we used until that time. And then we have 2 others that just, get in the courier ID on a different way, but basically, these just order them by the time, just grab one and grab it off that courier ID. And then I took the one with the most locations, and I benchmarked it against that. So like I had one with, I think, 2.3 million locations. I was like, OK, let's benchmark it against this. And then I saw like, OK, with courier IDs, it's much faster, together with full custom, than the DB view. OK, great. I did this. Job well done. I deploy it. Deploy it. Boom. One error, another error. Then there's a gazillion errors. And I was like, what? I'm the benchmarking guy. I benchmarked this. This is faster. Like, how does this keep happening? So I rolled back the release, and I was like, what the hell is happening? And so, like, yeah, I was really confused what happened. And then I used the inputs feature in Benchee, which is basically you can give different inputs, and all your benchmarks will be run with these different inputs, like you saw a bit before with the mapping thing. So we have different courier IDs in the database that have everything from no locations to 2.3 million locations. You pass them into the config, and then you pass in the courier ID into the function, and then into the query, basically. And that's the result. To highlight this, with 2.5 million locations, it is much faster with query IDs and full custom, but otherwise, it's much slower. It's by far the slowest, and the old implementation was better. So what happened, I was like, how does this happen? How is it slower with like no locations? So the ones that know Postgres knows what's happened next, explain, analyze, OK, cool. You do an index scan backward using courier locations time index, cool. But then you do a filter on courier ID. Basically, that means Postgres sorted all the locations by their time, and then went through the entire list to find the one with the courier. The problem here was we had an index, both one on courier ID and one on the time, and so it shows that one and couldn't use the other index because mostly Postgres can only use one index at a time. And so no locations was the slowest because it needed to scan the entire table. It sorted it, but then needed to scan the entire table. The fix for that is very easy. You use a combined index, you use it on courier ID and on time, and then all of a sudden, it's blazingly fast for no locations, 20K locations, 200K locations, and 2.5 million locations. And so this is just sort of like a small example of like how Benchee has helped me in my actual work with some stuff. And also another example for inputs actually matter. Like I thought I knew what I was doing, I didn't. And so like sometimes the edge case is not what you would expect. Sometimes having no inputs or no hits is actually much slower than having like 2.5 million hits. In the same vein, this is a benchmark right now on the Ecto mailing list that's shared from like the SQL Elixir package, which is just about generating an SQL query in different ways. And so if you look at it, it goes like, oh, wow, this approach is like, Ecto is 70 times slower and like consumes almost 140 times more memory than this approach. So this is much better, so we should all ditch Ecto now, right? And my question is, does it matter? Because this is a benchmark about generating SQL queries. It's not about running the SQL query. And like about any SQL query that you will run takes like at least a millisecond, usually, round trip time, getting it back, processing all the results, whatever. And like this is why Benchee has this additional output. So it tells you that this is actually like 6 microseconds slower. And like if you're doing a database query, do 6 microseconds actually matter? I would say no. And so that's one of the things that sometimes people hyper-focus on benchmarks. They see like, oh, wow, 70 times slower, oh my God, But actually, in the actual context of the application, it doesn't actually matter. So I really encourage everyone to like run your own benchmarks in your own application with what matters for you personally, and then see what's faster, not just some benchmark that some dude puts up on the internet, including me. Some lessons learned from like this entire journey of Benchee. So 1.0 for me was always like a really massive point in time with Benchee. And 1.0 happened about here in Benchee. And you can see there were a lot of time afterwards where there wasn't any commits. There's another reason for that, but one part of that was also for me, 1.0 was always the point where I would say like, now Benchee has everything that I ever wanted Benchee to have. Like if I don't commit anything to Benchee anymore after 1.0, that's fine, basically. But there were a lot of other options for what could have been a 1.0 release. And I today think that I would have probably been better off calling these other options already 1.0, 2.0, 3.0, 4.0. Like I think sometimes we're too scared to put that 1.0 label on something. So there was 0.6.0 where actually switched the arguments around. So if you can see in the first couple of versions, Benchee took the configuration as the first argument and the jobs as the second one, whereas the idiomatic thing to do is have the main data structure as the first argument and the config as a keyword list as a second argument. Although I still disagree with keyword lists being used for options because I still think like when I have options, I only want one thing. I don't want to have possible multiple values for a thing. But I should, I and also you by extension, when you design a library, should put your personal feelings aside when there's like an established community guideline. Follow that guideline, be idiomatic in the code base. 0.6.0 also had inputs, and it was the first one that had Benchee HTML. 0.10 was what I call the scenario revolution. We reworked basically the entire internal data structure of Benchee, which was just me and my, at the time, co-maintainer, Devin Estes, sitting together and just talking about naming and wording for like, and data structures for like 3 hours, which was amazing. And it was also the introduction of the very complicated hook system that is super cool for like 1% of you. But then it's really, really needed. And 0.13 actually introduced the memory measurements. And I won't go into it too much, but like memory management on the Beam is amazing. Like each process has its own, memory, does its own garbage collection. And then, when the heap and the stack meet, then the garbage collection is triggered. And it's really cool to learn about and was really hard to get memory measurement right. And Devin has an entire talk about it, which he gave at CodeBeam Lite Berlin. So I really encourage watching that talk if you want to learn more about memory measurement. Both memory measurement, but also memory management on the Beam. So another pattern that I think is really, really cool is that we did a 0.99 version, which was basically, you can install this version, and once it doesn't throw any warnings anymore, then you're good to upgrade to 1.0, which is also what I think Elixir wants to do whenever Elixir does a 2.0. And I think this is a very user-friendly way of helping people upgrade libraries. So, but like, what else happened in this big chasm here? Like, if you look closely at the dates, if you can read them, you know that at some point their COVID hit. At some point, Russia further invaded Ukraine, which for me was pretty tough because my best friend is from Ukraine. I've been to Ukraine all 3 pre-COVID years, and I have friends in Ukraine, so this was really tough on me. At the same time, there were layoffs and stress at work. the beautiful bunnies that you saw before, their health was degrading, and that was tough. And as a result of all of that, I got some ARM problems, and I couldn't actually, for a while, I couldn't write code. I couldn't play games. I couldn't do any of the things I usually like to do, which had to do with all that stress, with improperly carrying these bunnies, and to do lots of physical exercise. Now, why am I telling you all of this? Because things happen. I told part of the story in a talk I gave at AlchemyConf, and Ugo, the one that runs the Elixir newsletter, he actually came up to me. He's like, "Oh, Toby, thanks for telling that story. Now I know why there was this one pull request in Benchee for like half a year or something. You never responded to it, and you never did it because you really couldn't, and that's tough." And so, we're all humans, right? And humans sometimes aren't doing that good, and so please also be lenient with your open source maintainers. A couple of more stories of successes and failures. Although, yes, I'm approaching time, but it will be fine. So one of my other things is you could see that I always use timertc in Benchee. And this is the implementation of timertc in Benchee. Yes, this is Erlang code. I can also sometimes know halfway to write Erlang. And one thing that is interesting here is that it hard says, I convert whatever time unit I got from the native time unit to microseconds. And that for me was really, really cool because I was like, oh, wow. What is actually the time precision that a lot of these have? And I figured out that, especially in Linux, I can get you almost nanosecond time precision out of the beam. And so I re-implemented this function, and then from then on, sort of in Benchee, you had better precision. And by the way, this is small I. This is an old version. That's the version that I work with. But in OTP 26, actually, this function was updated so that it also takes in optional argument of the time unit that you wanted converted in. So that I could just use the new function if I only supported OTP 26 and further. That led me thinking more, because now I had precision that was really good. Because one thing, I want to give you the best measurements of your functions, right? And so there's something that I call function call overhead. This benchmark, just returning a 0, that should show up as 0 time spent, because it doesn't do anything. It just returns basically a constant. But it still shows up as depending on the system, let's say 9 nanoseconds, 10 nanoseconds, something like that on my machines, because there's an overhead of calling that function, And I implemented a system to do that, to measure what the overhead is and to deduct it. The big mistake was that I set it true as a default, which is not a good thing to do, because while Linux might have nanosecond precision, macOS doesn't. macOS has a microsecond precision, and sometimes Windows systems don't even have that. And so that is very not a good thing to say as a default, because then it actually makes your benchmark defaults wrong, because then it always deducts a microsecond or whatever, and that's not what you want to have, because then your measurements are actually wrong. So that was something that needed fixing. I had much more fun with Macs as well. Such as here, this is a really long thread where it's basically the Mac system was telling me it had nanosecond precision, but it didn't actually. And so I have this code to work around it, where the fun part is down here. I have this thing called trust the clock if it's macOS, and the Erlang version is from before 22.2, because there was actually an Erlang fix needed for that. Then I'm just okay, don't trust whatever the clock tells me. We assume it's microsecond precision, which also, one of my few gripes with Erlang is, how many numbers does an Erlang version number have? Anywhere between 1 and 4, so that is a bit hard. At least, I don't know, maybe somebody knows a function in OTP itself, so I can check if a version is included in my fix, but I wrote quite a long module, which is this Erlang version includes fixes from to handle that. Another thing is that naturally you would assume that each scenario has its own process. So each benchmarking function is run in its own process, which is what most, let's say, educated Beam people would say. It was actually a byproduct of somebody implementing the parallel feature. So this is what it looks like. And I remember thinking oh, if I only have one thing, I still create a new process. I was very new to the Beam, don't judge me. And I was oh, it's probably fine to launch a new process for it. So this one ended up being correct by accident, because you actually want each new process, each new benchmark to have its own process. This goes further. I'll probably skip about it, but basically, the design held up very, very well, but you had this one gigantic data structure, the suite. And when you send that to a new process, especially for statistics and formatters, That then meant you sent along all of that data along, including the input. So if you had an input of like 1 gigabyte, it would send it along to the process because everything is copied on the beam. And that led to some degraded performance. So you got to learn to send only what you need, and even better, help others avoid making the same mistake. So like you can read that blog post, but like after I found out, I added documentation to both the task module and like another entry to the anti-patterns in the Elixir documentation so that nobody else basically does the same dumb mistake I did. So future of Benchee, there's a couple of new features like the maximum sample size. Essentially, because the benchmarks are so fast, sometimes you gather like 100 million samples and then statistics calculation gets like a little bit slow. So you can limit that to only like 1 million. We'll have outlier removal soon. The statistics code is already there for that. So like that especially comes in handy because you get the times when like the garbage collector triggers to remove those as well. Sadly, I think Brian is at the Erlang Solutions hub stand right now, but like he discovered a bug on the interaction between the parallel feature and the hooks feature. That will be fixed. And like maybe also we'll get a logo because Benchee doesn't have a logo. And like some people like this I really like. So Benchee's name comes from the Benchee in Warcraft 3, which is like, so that's why it looks like that. But then other people had these more sensible ones. But then my friend Peter came along and suggested this logo, which much as here was a community favorite. And so then this logo, and my friend Tessie also this logo. I was like, okay. I like the other logo better, but like I think everybody else likes these logos better. So to wrap it up, like please run your own benchmarks. And also, when you create something, you learn as you go. Like a lot of times people come to me and they're like, oh, Toby, I could have never written Benchee. I don't know as much about the beam as you do. And I hope through sharing like all the stupid mistakes that I made so far, you've learned that I didn't know a lot about the beam. And so I always say, I didn't write Benchee because I knew the beam well. I know the beam well because I wrote Benchee. So it's a learn as you go type of situation. The other thing is also better isn't good enough. You need to go somewhere and tell people Benchee, write blog posts and whatnot so that people actually start adopting it, which is very important because for a long time, Benchfellow was still way more popular and took quite a while to overtake it. But one of the best things for me is the people I met. So like the first time I gave a talk about Benchee was at Elixir Live in Warsaw. And that's when I met Michał Muscala. And like we kind of became friends. We talked about benchmarking, NCI, and all of that stuff. And I also feel really glad that I can help the ecosystem through like providing a tool that makes it easy to show what's faster and what's better. But like overall, we're all human. Sometimes maintainers don't get to their work, but it's about the humans that you meet. And so this is my friend Pablo, and I met him literally because he made a pull request to Benchee where he implemented the profiling option. And like I just liked interacting with him on the pull request so much that we stayed in touch. And we're very close friends by now. This is a photo from when I was visiting him like 2 months ago in Galicia. And we both, each year, we say multiple times to each other, I'm so glad that you made that pull request at the time, or I'm so glad I made that pull request. And so like through open source and all the work, you also meet some amazing people. And so keep that in mind. Thank you.
Yes, thank you, Toby. Any questions? One question.
Hi, just since I was using the Benchee, the one thing which I was actually interested in, you have a time for duration of test. Why don't you have iterations? Because this takes some things execute very quickly, and you get, as you said, a lot of statistics for runs. One thing is executing too slowly, maybe just only once, So you have to give really big timeout or duration time or iterations will be very useful. And another question is the memory measurements, and you do like a separate run or it's done at the same time? That's just,
Okay, great question. So a small question is like, why do we take like a time for how long it needs to run versus like a number of iterations that it runs? And like you have the same problem with the iterations. You need to figure out sort of like, if you configure like 2,000 iterations, like it might run for half an hour or something, you don't know. So the goal of specifying time instead of iterations is like to make it more predictable. So like how long will the benchmark run? And then if you don't have enough, you can run it again, but you don't have it running forever and you don't know when will it finish. So it's like predictability from the user point of view. And the other question was, are memory measurements done like in a separate process or like together with the time measurements? And no, like they have their own time, and so they run completely separately. And also, so you can go into like I think Benchee collect, and there's the different implementations of all the gatherers, we call them, or collectors. And you need to run it separately because for memory measurement, we actually, for each iteration, we start a new process that has that, and then, we need to trace all of the garbage collection events from that process. And similarly, reductions are also done in their own process. So they're completely separate and configured separately. But very good question, thank you.